Okay, welcome to this edition of the Henstitute, in which we're going to talk about velocity versus time graphs. You should have an assignment where you use the gizmo simulation to look at velocity versus time graphs, comparing them to distance time, or I often refer to them as position time. Now I want to kind of extend that. They don't go through all the tidbits I want. They look at situations like this G to H or B to C, where the velocity stays constant and you've got a horizontal line. I want to look at places where the velocity does not stay constant. So there are three things I can actually find from this graph of velocity versus time graph. The first one is obviously velocity. I should be able to find the velocity of every single point by just coming across and looking at the y-axis. I can give an ordered pair for it where I give 2 bits of information, but I could just give 1 bit. So for example, F is sitting here at the 30-second mark, and over here it's at 10 meters per second. So at 30 seconds, this object is going 10 meters per second. That's in essence what that point tells me. So that's the 2 parts. For some reason this didn't copy, but this axis in the middle is time in seconds. The second thing that you can actually find from a velocity versus time graph is the acceleration. Since acceleration is defined as a change in velocity over a change in time, velocity is on the y-axis and time is on the x-axis. This is kind of like saying that you're finding the slope of the little line segment. So in a situation like G to H, where the line is horizontal, this would represent that you have an acceleration that's actually equal to 0, because there is no slope. It's traveling at the same velocity at G as it is at H and all points in between. But a situation like E to F, now this object is actually accelerating. And so I should be able to find it. So if I find the point here at E, it's at -8 and the time is 20. So the ordered pair is 20 seconds and -8 meters per second. Remember, the negative just indicates that it's going in an opposite direction. So maybe negative means it's moving to the left and positive means it's moving to the right, something to that effect. So even though it's going to go from moving in one direction to moving in an opposite direction, I should be able to still find the acceleration from E to F by finding that change in velocity over the change in time. So I'm not going to worry about one being negative or positive. So my final velocity here is the 10 meters per second. And my initial is the -8. So I'm subtracting a -8. So it's really like they went from -8 down to 0. So in other words, they slowed down. And then they went from 0 up to 10 meters per second. So then they sped up in the opposite direction. But the acceleration is always going to be positive in this case. In other words, opposite the way it was originally going. My time is going to be 30 seconds minus 20 seconds. Could chunk that out. You basically got 18 meters per second over 10 seconds. And we would write that as 1.8 meters per second squared. So that's one of the cool things about a velocity versus time graph. You can actually find the acceleration of an object. If it's a horizontal line, obviously it's not accelerating. If it's a vertical line, it would mean an incredibly fast acceleration. We don't get perfectly vertical lines. We can get pretty steep, however. But you can also have positive and negative slopes. So you can have positive and negative accelerations. It does not mean speeding up or slowing down. It just means whether it's in the same direction of the object or opposite directions or whatever. It just indicates a direction. So in this case, maybe positive means to the right and negative means to the left. If you have a positive acceleration, it means that it's accelerating to the right. If you had a negative acceleration, like from A to B, that would actually mean that you're accelerating in the opposite direction or to the left. So this object from A to B is slowing down because it's moving in the positive direction, but the acceleration is opposite that. The last thing that you can actually find on this type of graph is displacement. We're going to be dealing with this more, but I want to kind of do an introduction to this. So define displacement, this is kind of weird because you're like, how do I find that? I don't have that information in there. It doesn't seem like I should be able to find that. But you can, because you should be able to actually look at your change in velocity and use that to kind of help you out. So displacement normally would be your average velocity multiplied by your time. This is just a kind of a manipulation of the definition of average velocity. But how do I find an average velocity? So if I'm looking for a short little segment, the average velocity of something can be found by taking the velocity at one point plus the velocity at another point and dividing by 2. So if I'm looking for a section where the change in velocity is a constant, or in other words, the acceleration is constant, I can replace my average velocity with that and then multiply it by a time. So this is actually a way to do that. So if I was looking for the average or the displacement from A to B, what I would do, my displacement, I'm going to call it X just for the fact that it's moving in the horizontal direction is an easy one. I would take one of my velocities, which in this case is 14 meters per second here at A. I would add to it the velocity here at B, which is 6 meters per second, divided by 2. In other words, let's find the average velocity during that time. So 14 plus 6 is 20. 20 divided by 2 is 10. So this thing is averaging 10 meters per second. So it's slowing down, but it's averaging 10 meters per second. So I'm just taking the average of the endpoints of that little line segment. And then I'm going to multiply it by the time interval that that's happening for. So A starts at 0 seconds. B is at, it looks like 5, 6, 7, 8 seconds. So the time interval would be 8 seconds. 8 times 10 is 80 meters. So during that first little section, this object would actually travel 80 meters. Now, interestingly enough, this equation is something that we're going to be dealing with more, and it's kind of a neat little concept. It'll work for everything, even something like E to F, where it crosses over the axis, you'll have that, and so it'll actually find it. Also, for something like D to E, where both of these have negative velocities, we actually are going to find the average of those negatives and keep them as negative. This is going to be a negative displacement. What does that mean? It means that it's displaced itself in the opposite direction from something else. So it's displaced itself to the left if it's negative, to the right if it's positive, south, north, whatever. So these are the ways we're actually going to find it. So these are things we can actually find with a velocity versus time graph. I hope you enjoyed this edition of the Henstitute.